Natalia.
Hello, everyone. So I came from Switzerland to present to you our work on speech quality assessment. So why do we need it in the first place? There are several applications. For instance, any speech enhancement application. You have a software working on speech enhancement, and you want to know how it is performing and what is the quality of the output file. There are several industry standards already out there. For instance, POLQA. I'm going to focus on POLQA in my presentation because it is a widely used industry standard, and I'm going to compare our work to POLQA. So all these methods are intrusive, meaning that they all require a clean reference file. So anytime you want to evaluate your file, you need to provide the same file in a perfect quality. And you don't always have access to such a clean reference, for instance, in speech denoising application or any real-time application. So we want a non-intrusive method. But this is not their only issue. So let me play an example. I hope that sound works well.
The young inventor had just noticed his friend lying pinned beneath a heavy beam nearby.
So the quality is not that bad. There is no background noise, and there is some reverberation. And if we ask POLQA to evaluate this file, it will output a score below 2 in the range from 1 to 5, when 5 is the best quality. So it is rather low. And POLQA is intended to predict the subjective score, the score that a human judge would give to the file. So if we ask human judges to evaluate this file, they would evaluate it as 4.63. The difference is very big, and it comes from the fact that POLQA was not intended to evaluate the reverberant speech. We can see it on the following plots. So on the left, we have subjective scores. On the right, we have POLQA scores. Each point on the plot represents a file with signal-to-noise ratio on the horizontal line and reverberation measured by T60 on the vertical line. So in the left, we would have the worst noise, and on the top, we would have the worst reverberation. And the bright color of a point means a high score, and the dark color of the point means a low score. And on the bottom of the plot, where we have no reverberation, T60 equal to 0, we see that both scores more or less agree. But as soon as we increase the reverberation, we see that POLQA scores drop very low. They almost don't depend on the signal-to-noise ratio anymore. And especially we can see it in the files when there is no noise in the right column. People are actually very tolerant to the reverberation because we are used to it in the real life. And POLQA does not represent it very well. So this is a big problem because POLQA is intended to predict the subjective scores, and it is used in many applications. In many applications, you are required to achieve a certain POLQA score. So we want an alternative non-intrusive metric. So we collect a data set to train our model on. We use the LibreSpeech dataset to take our clean samples, on average 6 seconds long, 3,000 of clean samples. For room impulse responses, we use the OpenSLR dataset. There are various conditions, various shape of the room and distance to the mic, with T60 below 1.4 seconds. And for background noises, we use free sound. Again, different kinds of noises, keyboard typing, chairs, cafeteria. And we randomly pick a noise with signal-to-noise ratio from -5 to 25 decibels. So we mix everything together. For every clean sample, we pick at random several room impulse responses and several background noises, which leads us to 30,000 of samples, almost 50 hours of speech. And this is a lot. So now we want to label them to train our model on it. And we must choose between either labeling the data set with POLQA, but as I said, it wouldn't correspond very well to the subjective scores, and we want our model to predict human perception, not POLQA scores. Or we can rate everything with a subjective test, so run a survey and ask human judges to rate our samples, and this is very expensive, 30,000 of samples, it's a lot, and we need to collect several scores per each sample to compute the average, so this is not possible. Instead, we choose a third option. So we split our data set in two parts. We have a bigger part with more than 25,000 of samples, and we evaluate them all with POLQA, easy and cheap. And the other part of the data set with more than 4,000 of samples is rated subjectively. So here we ask human judges. Why do we do so? So as I said, POLQA, rate the entire data set with POLQA is not an option because we want to predict human perception. So we rate as many samples as we can, and then we would train our model on this small part of the data set. Now, usually in the beginning of the training, you initialize the variables randomly. In our case, instead, we use transfer learning. So first, we train our model, which I will show later, on the bigger data set with POLQA scores. So our model, in the end, learns to predict POLQA scores. And after that, we fine-tune our model on the subjectively rated data set. So yes, I said that POLQA scores do not correspond very well to subjective scores, but this is still better than just initialize our variables randomly. Okay, so we run our subjective test. We ask 3 questions per file: signals quality, background intrusiveness, and overall impression. In our work, we only keep the last one, but it would be interesting also to use the first 2 scores in the future work. And we compute a mean opinion score for each sample. We want to make sure that we can trust to the scores that we receive. So even before the user can access to our test, we make some verification, the hearing ability of the user, the environmental setup. Especially we want to avoid the denoising headset because that's not the point of the test. We also have gold standard questions. So these are mixed into the test. These are usual samples from our data set, but we expect a particular answer for these files because they're either bad or very good. So if the user gives another answer that we expect, we remove all the answers of this user. We also have trapping stimuli. So these are the samples that are interrupted after 2 seconds. And there is a motivational message saying that it is very important for us that the user pays attention and asking choose a particular answer. And again, we remove those who didn't answer with this answer. We also look at the variance of ratings. So variance of ratings below 0.1 for a user means basically that the user gave almost always the same rating, and we don't want this, so we also remove them. Okay, so some statistics. We have almost 300 of listeners, almost 100 of samples per listener on average, and we have 7.5 scores per sample after cleaning the entire data set. And on the plot, we see that not all the users use the entire range of scores. So reminder, the scores are from 1 to 5, and on the right column, we see that almost everyone used the 5 available scores. But 20% of the users did not use the entire range of scores. So we could have the following situation. One user would rate from 1 to 4, another from 3 to 5. What does a rating 3 mean here? So to avoid this, we scale all the ratings to cover the entire range from 1 to 5. Okay, so let's go to the model. We use the mel frequency substrate coefficients as our features. We only evaluate the first 5.5 seconds of each file because this is the shortest. We have to have all the files of the same length. And you can see the example of what the MFCCs would look like for a very good quality file and a very bad quality file. This is how our model looks like. I won't go into much details here. We were inspired by a previous work, which is cited below. And in short, we have 4 convolutional layers and 3 fully connected layers. We use the rectified linear activation function, Adam optimizer, and the loss is computed using mean square error. Okay, so let's go to the results. The proposed model 1 is our model trained on the small subjectively rated set directly. This is here just as a baseline. The second model is pre-trained on the POLQA, the biggest dataset with POLQA scores, and then fine-tuned with the subjectively rated dataset. And finally, the third and the last model is the same one, but here we are using descaling of the mean opinion scores. And this one shows the best results. And all three are still better than POLQA. Now, it is also interesting to check the average variance of mean opinion scores over the entire dataset, which is 0.5. This means that, on average, a user tends to rate a file further away from the mean opinion score of this file than our model. So this is interesting to know. Now, we would also like to compare our model to other models available publicly. But for this, we would need another data set, because it would be unfair to compare our model to other ones using our own data set on which our model was trained. So, of course, there are not many data sets available online with subjective scores given already. But we found one data set which doesn't have the subjective scores, but we know the average mean opinion score of the entire data set, which is 3.4. And we expect that the best model would be the closest to this mean opinion score if you compute the entire average of the whole data set. So we admit that this is not the best way to compare the models, but for now, this is the only thing that we could do. And in our example, our model scores a lot closer to the subjective test than POLQA. That's it.
Questions from the audience? Yeah. Can you move and take the microphone, please?
Okay. Congratulations on your work. My question is related to the raters. I would like to know if they are some kind of experts in this kind of problem, or if they are like general listeners. And the second question is if you gave some sort of reference of what would be like a very poor audio, and what would be a five rate, something like this.
So yes, thank you for the question. I didn't go into details indeed about the subjective test. So we used the Mechanical Turk platform. So it is an Amazon provided platform that allows you to run subjective tests there. And so these are just online users from the world, and we only restricted to the native English-speaking users because we have an English data set. So they are not experts. And we have a training part where we first show five or six samples to the user, and the user can rate them, but it is not counted in our data set after that. This is just to show to the user. And here we make sure to show to the user the worst and the best available files that we consider worst and best.
More questions? I have a question. Two, actually. First question would be, in your distribution for reverberation, you only look at T60. Now, I was taught that this is a limited representation of how bad reverberation is. You also have early to late ratios and other metrics. So why did you restrict to only T60?
So this is a good question indeed. So we only refer to T60 because it has been already provided with the data set of the Riemann plus responses. And indeed, we kept in mind that it is important to also look at other metrics, and it is left to the further work because, yeah, it's it's important to also compute the other metrics and look at them and find the patterns.
Yeah. So my second question would be, so you've shown that this subject normalization is important to get a good fit. Now in the first talk by Tilo, this was not mentioned. So could the two of you fight over if this is necessary or not?
In the case of telephone or not, I would say. What would you say?
I'm not sure actually. I haven't seen previously in other works the mention of the subject-specific scaling. So we wanted just to test, but it's interesting to know that in recommendation systems, it is a very basic thing to do when you work on the dataset. So I just wanted to bring it here and try to see the results. So I guess we may fight.
It's not common practice yet.
Yes.
All right. More questions?
Let me try. Oh, there is an online question. Okay, it says, for training, you just split the data randomly, or you use the samples with the most confusing POLQA scores to be assessed subjectively?
No, it is just a random split.
Short answer.
Yes.
Yeah.
You mentioned the Mel frequency capsule coefficients. Did you use the standard 13 in deltas or not?
Yes, the standard 13. By the way, we were planning to also use other features because MFCCs may not extract everything. There are some like pitch or voice activity. It would also be interesting to test. The time was limited, but it's also interesting to test in the further work.
Yeah, for sure, because MFCC indeed throws away the pitch, which can be very useful for speech communication, for sure, tone languages, etc. Oh yeah, you mentioned English, Libre speech. What relevance is the language when you're doing speech quality evaluation?
Oh, so we only started with English to make it easier at the beginning. It would be, of course, interesting to go to other languages, but I guess depending on the language, the quality, the perceived quality may also change. Yeah, it's an interesting question to study. I'm not sure that I'm able to answer it now.
Just one interesting point in your paper, you talked about noise from the pre-sound database matching the most realistic scenarios, like squeaky chairs. Well, are squeaky chairs most realistic?
For the office Zoom meetings, for example.
All right. No further questions?
Okay, thank you.
Thank you.